Trig Homework 9 starts off where we're graphing, and we have a line that is in slope-intercept form. We can either graph by making a table or by using the slope and the y-intercept. I personally like to use the slope and the y-intercept, but some people like to do the table. If I'm going to make the table, what I want to do is put values in for x that, since here we have a fraction, would eliminate our fractions, and so we want to use multiples of 5. So I might use 0, 5, and 10 when I put numbers in for x. You could also use a -5 if you want to use a -5. So 1/5 times 0 is 0. 0 minus 4 is minus 4. 1/5 of 5 would be 1 because the 5s would cancel out. So 1 minus 4 would be -3. 1/5 of 10 would be 2 because 5 goes into 10 twice. 2 minus 4 would be -2. And if I did 1/5 times -5, I'd get -1. -1 minus 4 would be -5. I only really technically have to have 2 points. I like to do more than 2 just so I know my line is straight. But we have, whoops, that didn't go anywhere near where I stuck my pencil, but 0, -4 is going to go way off on my plotting points. All right, let's see if it goes where I want it to now. So 0, -4 over 0, down 4. 5, +5, -3. 1, 2, 3. And then 10, -2. 1, 2. And if I did -5, I'm at -5. 1, 2, 3, 4, 5. And so you can see that when I connect my dots, if I could draw straight, I could draw my line. Now that's one way of doing it. Putting in numbers for my x, finding my y, plotting my points. The other way is using my slope and y-intercept. If I have the equation y equals mx plus b, we know that the end number is the y-intercept. So in this case, my y-intercept is at -4. I should be touching the y-axis at -4, which was that point right down there. My slope is 1/5. We know that the top is the change in the y direction, the bottom is the change in the x direction, and so we're going to go up 1 and 5 to the right since they're both positive. So from that marked point, my y-intercept, if I go up 1 and over 1, 2, 3, 4, 5, there's my next point. Up 1 and over 1, 2, 3, 4, 5, there's my next point. Also keeping in mind that if I do have a positive slope, I could make it a negative over a negative, right? -1 over -5 is still positive 1/5, which means I would go down and to the left, since they're both negative. So if I was here and I went down 1 and to the left, 1, 2, 3, 4, 5, sure enough, you can see I hit all those same points that I had in my table, and it's probably a whole lot quicker than making the table. So I prefer that second method, but if you want to make a table and plot points, you can. The second one then, if I look at that, my y-intercept is going to be at a +2, so I'm going to mark 2 on my y-axis. My slope is 3/4, so I'm going to go up and to the right since my slope is positive, so up 1, 2, 3, and over 1, 2, 3, 4. Up 1, 2, 3, over 1, 2, 3, 4. I could go down and to the left. Down 1, 2, 3, and to the left. 1, 2, 3, 4. You can see my dots line up, so I can connect my dots. My slope is positive. It goes uphill as I went from left to right. My y-intercept was at 2, and so there's my line. The third one then, I'm going to graph y equals -1/2 x plus 4. Again, if I look at that, my y-intercept is at +4. My slope is a -1/2, which means I could write it as -1 over 2 or a +1 over a -2. My negative's either on the top or the bottom, not both. So if I do this one, I would go down 1 and 2 to the right. Down 1, 2 to the right. Down 1, 2 to the right. If I did it this way, I would go up 1 and 2 to the left. So up 1 and backwards 2, up 1 and backwards 2. You can see my dots still all line up. As I connect the dots, I'm going downhill because my slope is negative and my y-intercept was at 4. 4, 5, and 6, those are those special cases where you don't have both the x and the y. You either have an x equal or a y equals. If I have x equals my number, my line is going to end up going vertical. If I have y equals my number, my line ends up going horizontal. So they call these special cases because it's not the normal form of the line. What happens here, if I would make a table and it tells me x equals -5, it means every single point in my table would have to have an x value of -5. The y values could be anything. Could be 0, could be 2, could be -3, whatever I want them to be. So if I plot those points, -5, 0, back 5 and up 0, -5, 2, -5, -3. Notice all my dots end up lining up in a vertical line, straight up and down. So normally what I do, instead of making a table, is I look and say, okay, x equals -5. On my x-axis, I mark -5. I know my line has to go vertical, so I just mark a point that's straight up and straight down so that I can connect my dots and draw my line. So number 5, we're graphing the line y equals -8. Since it's y equals my number, I know it has to go horizontal. So y equals -8. -8 on my y-axis is down there. Since my line has to go horizontally, I just mark a point to the left and to the right, or the right and the left, and then I can draw my line, and y equals -8 looks something sort of like that. And number 6, graphing the line x equals 1. If it's x equals my number, I know my line again goes vertical. So x equals 1. On my x-axis, I mark where 1 would be. If my line has to go vertical, I'm going to mark up and down somewhere from that point so that I can then draw my line. And on Alex, they'll make you draw it straight because you have to use the ruler. So just mark a couple points, draw your line either straight up and down or straight across. Alright, the next ones we're graphing ones that are in standard form by finding the x and the y-intercept. You could also rearrange it and solve it for y and put it in slope-intercept form. I like to do the x and the y-intercepts. So if I am going to do the x and the y-intercept, it's kind of like I'm making a table. For the x-intercept, I'm putting 0 in for y and solving. For the y-intercept, I'm putting 0 in for x and solving. So if I put 0 in for the y, basically it's getting rid of the y term, and I get 7x equals 28. Well, 28 divided by 7 is going to give me 4, so my x-intercept is going to be at 4. For my y-intercept, it's like I put 0 in for x. If I put 0 in for x, I get -4y equals 28, and when I divide by -4, I get -7. Now on these ones, the plot point tool will be available. It looks something sort of like this, so if you wanted to type in the ordered pair, you could. Sometimes you will get fraction answers and you have to use the plot point tool. If they're nice integers, nice whole numbers, you can plot them easy enough. My x-intercept is at 4. My y-intercept is at -7. I've got my 2 points, and I can draw my line. So number 8, if I'm going to do my x and my y-intercept, again, when I do my x-intercept, the y is 0. So if the y is 0, the y is gone. 3x equals 3. When I solve that, I get x equals 1. If I'm doing the y-intercept, I'm putting 0 in for the x. If I put 0 in for x, I just get y equals 3. There's not much solving to that one. So again, I can mark my points. My x-intercept is 1, my y-intercept is 3. I've got my 2 points. I can draw my line. And on my third one here, if I'm doing my x-intercept, I'm putting 0 in for y. So 2x would equal negative 12. Negative 12 divided by 2 gives me an x-intercept of negative 6. If I do my y-intercept, I'm putting 0 in for x, so negative 3y equals negative 12. When I divide, I get a positive 4. So my x-intercept is at negative 6. My y-intercept is at positive 4. I can then connect my dots and draw my line. All of our examples had nice integer answers. You will sometimes get ones that aren't integers, that are going to be fractions, and then you have to use the plot point tool. But most of the time it works out pretty nicely by just finding the x and the y-intercept. Graphing a parabola in the form of ax squared plus c. There may be a coefficient in front of your x squared, but here this is going to shift my graph up 2. Normally it'd be at 0, 0, but it's going to go up 2 places. I know that because of the shift on my graph. What they're going to do on here is basically, because you don't have a horizontal shift, you just have the vertical shift, they're going to have you use the points negative 2, negative 1, 0, 1, and 2. Because normally the vertex of your parabola, y equals x squared, is right here at 0, 0. So just centering it around the middle. So they're just going to have you plug the numbers in and solve. Negative 2 squared is 4, 4 plus 2 is 6. Negative 1 squared is 1, 1 plus 2 is 3. 0 squared is 0, 0 plus 2 is 2. 1 squared is 1, 1 plus 2 is 3. And 2 squared is 4, 4 plus 2 is 6. If I have a parabola, those match up, and that's in the middle because it has to look like that U shape. So I'm just going to plot my points. Negative 2, 6, negative 1, 3, 0, 2, 1, 3, and 2, 6. And when you hit the graph button, it'll connect the dots and draw your parabola so it looks something sort of like that. So the vertex should be where that shift is at positive 2. Since my coefficient for my x squared is positive, my parabola is going to go upwards. If it were negative, it would reflect it against the y-axis and would end up being down here. So number 11, now we threw a coefficient in front of my x squared. This one is going to shift down to negative 1. I can see that because there's a minus 1 on the end. But again, they're just going to have you make a table and plot points. Negative 2, negative 1, 0, 1, and 2. And doesn't matter if you want to start with the 2 or the negative 2, whichever way. But if I do that, negative 2 squared is a positive 4. 4 times 2 is 8. 8 minus 1 is 7. Negative 1 squared is a positive 1. 1 times 2 is 2, and 2 minus 1 is 1. 0 squared is 0. 0 times 2 is still 0. 0 minus 1, negative 1, where my vertex is. 1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. So I've got my points. I can plot my points. Negative 2 up 7. Negative 1 is up 1. 0 is down at negative 1. 1 is at 1. And 2 is at 7. And so again, I can see that my vertex is down there at negative 1. And my parabola is going upwards since my coefficient was a positive 2. And number 12, same kind of thing. If I make my table, negative 2, negative 1, 0, 1, and 2, plug my numbers in. Now make sure you do the exponent first and then apply the negative. So negative 2 squared is 4, but there's a negative in front, so I get negative 4. Negative 4 plus 2 is negative 2. Negative 1 squared is positive 1, but then I have to apply the negative, so negative 1 plus 2, positive 1. 0 squared is 0. You really don't have a negative 0. 0 plus 2 is going to give me 2. 1 squared is 1, but I've got the negative, so negative 1 plus 2 is 1. 2 squared is 4, but I have the negative, so negative 4 plus 2, negative 2. So negative 2, negative 1, positive 1, 0, 2, positive 1, and positive 2, negative 2. And then, of course, I can draw my parabola. Again, this one, my y-intercept is at plus 2. It has a negative coefficient, so my parabola is going upside down. All right, the next one's graphing a cubic function in the form of y equals ax cubed. There is no adding and subtracting on this graph, and so the center of your graph is going to be at 0, 0. So basically, they're just going to have you make a table with 0 being in the middle. So 2, 1, 0, negative 1, and negative 2. And then you're just going to plug your numbers in and solve to find your y values. So we're going to take 3/4 times 2 cubed. So 2 cubed is 8. 4 goes into 8 twice. 3 times 2 is 6. 3/4 times 1 cubed. Well, 1 cubed is 1, and 1 times 3/4? 3/4. 3/4 times 0 cubed. Well, 0 times anything is going to be 0. We pretty much already said the center is going to be at 0, 0. 3/4 times negative 1 cubed. A negative 1 cubed stays negative 1. Negative 1 times 3/4 is 3/4. And then 3/4 times negative 2 cubed. Negative 2 cubed is negative 8. 4 goes into there 2 times, so 3 times negative 2, negative 6. That should have been negative 3/4. 3/4 times negative 1. So that this is opposite of this is opposite of this, and that's 0, 0. So make sure you get the negative in front of your 3/4 there. Didn't write it down when I wrote it on there. So, all right, let's see if my dots show up where I want them. So 2, 6, 2 over and up 6. 1 is only up 3/4, just kind of estimate where that is. 0, 0, 1 and down 3/4, and 2, negative 6. So my graph is coming here, got a little curve in the middle, then shoots back down to the bottom of my graph. So most cubic functions will either come down, have my curve, and keep going, or be on the other side, come down, have my little curve, and keep going. Number 14 then, graphing y equals negative 11/8 x cubed. So again, we're just going to make our table, same values with 0 in the middle, and plugging our values in. I went in the other order this time, but it doesn't really make any difference. Negative 2 cubed is a negative 8. So a negative 8 and negative 8 would cancel out. I'm going to get a positive 11. Negative 1 cubed is negative 1. Negative times a negative is going to give me a positive 11/8. 0 cubed is 0. 0 times anything, still 0. 1 cubed is 1. 1 times a negative 11/8 is a negative 11/8. And 2 cubed is 8. The 8s will cancel out, so you get the negative 11. I've got my points. I'm going to plot them. So negative 2 is up to 11. Negative 1 is at 11/8, so just a little higher than 1. 0, 0, 1 and negative 11/8, 2 and negative 11. So our cubic function looks something sort of like that. Again, you'll use that little plot point tool, looks something like this, and type in your ordered pairs. You can do it for all of them, but for sure when you have the fraction, so that Alex can put that 11/8 in the proper spot. And number 15, we are graphing y equals 1/2 x cubed. So again, we're going to make our table. 2, 1, 0, -1, and -2, whichever order you want those in. And then plug our numbers in. So 2 cubed is 8, half of 8 would be 4. 1 cubed is 1, 1 times 1/2 is still 1/2. 0 cubed is 0, 0 times 1/2 is 0. -1 cubed is -1, -1 times 1/2 is -1/2. -2 cubed is -8, half of -8, -4. Plotting my points. So 2, 4, 1 is up 1/2, 0, 0, -1 is down to -1/2, and -2 goes down to -4. And my cubic function looks something sort of like that. (16, 17, and 18), finding the slope given 2 points on my line. M is my symbol for slope. Slope is the change in y over the change in x. So they'll tell you to take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now it really doesn't matter which one is point 1 and point 2. If I call that one point 1, here's my x1 and my y1, here's my x2 and my y2. And so I'm going to take the y value from point 2, which is -7. I'm going to subtract the y value from point 1, which is -3. On the bottom, I'm going to take the x value from point 2, which is 7. I'm going to subtract the x value from point 1, which is -9. So I'm going to have -7 plus 3, which is -4. And then I'm going to have 7 plus 9, which is 16. And of course, I've got a fraction, so I want to simplify that. So I'm going to get -1/4 for my slope. Now just for fun, if I do that same problem, but I do it in the other order, if I do the y minus the y, saying this is 2 and this is 1, I would take -3 minus a -7, and then I would take -9 minus just the 7. So I would have -3 plus 7 on top, and -9 minus 7 on the bottom. I would get 4 over -16, which again simplifies to the -1/4. So just to show you, the order really doesn't matter. That's just the order they're going to show you, since they're going to say I'm going to take the y value from point 2 minus the y value from point 1. So on number 17, if I'm going to find the slope of the line, the y value from point 2 is 6 minus the y value from point 1, which is -8, over the x value from point 2, which is 5, minus the x value from point 1, which is -3. So I'm going to have 6 plus 8 over 5 plus 3. 6 plus 8 would be 14. 5 plus 3 is 8. I can reduce that down. So 7/4 going to end up being my slope. And number 18, finding the slope again. The y value from point 2 is -1. I'm going to subtract the y value from point 1, which is -3. The x value from point 2 is 1, subtracting the x value from point 1, so minus the 3. So I'm going to have -1 plus 3 and 1 minus 3, so I'm going to get 2 on top. I'm going to get -2 on the bottom, and simplifying 2 over -2, I get a slope of -1 then. And 19, 20, and 21, finding the slope and the y-intercept of the line given the equation in ax plus by equals c, which is standard form. What we want to do is rewrite it in slope-intercept form. Slope-intercept form is y equals mx plus b, the m being the slope, and the b being the y-intercept. So all we're really going to do is rearrange that, solve it for y, so we can pick out the slope in the y-intercept. So I'm going to leave the 2y where it is. I'm going to move my x to the other side, so it's going to become a negative 4x, and then the minus 2 goes on the end since it was already on the right side. I'm then just going to divide by 2. So y is going to equal negative 2x minus 1. So my y-intercept is the minus 1 on the end. My slope is the minus 2 that's in front of the x. So on number 20, if I want to solve that one for y, negative y is going to equal a negative 4x plus 3. Moving my 4x to the other side made it negative. Dividing everything by negative 1 is just going to change my signs. So y equals 4x minus 3. My y-intercept, the minus 3 on the end. My slope, the 4 that's in front of my x. And number 21, same thing. I want to solve this one. I'm going to have negative 4y equals, I'm going to move my 5x to the other side, so negative 5x minus 12. I'm then going to divide everything by negative 4. So y is going to equal, negative over a negative is going to make that a 5/4 x. Negative over a negative, negative 12 divided by negative 4, positive 3. So my y-intercept is 3, my slope 5/4. Now there are those special cases that you have to keep in mind, that if you have x equals your number, your line is vertical, and the denominator would be 0, so your slope is undefined. And if I have y equals a number, my line goes horizontal, my slope is going to be 0. So just keep that in mind for those special cases when they ask you about the slope of a vertical or a horizontal line.